Hi class, in this video we are going to go over lesson 3.7, but this is actually part 2 of 3.7. So previously we did example 1 and we did not do example 2. So this is what we're going to cover in this video right here. So what we're going to do here are 3 by 3 matrices and just finding the determinant of them. All right, so I'm going to just rewrite this down here because the first step is actually to rewrite the first two columns to the right of the determinant. So 4, -3, -4. Let me actually zoom in here so we can get this nice and neat. And then the next column is -8, 2, 5. Okay? So then after that, step 2 is you're going to draw diagonals beginning with the upper left-hand element. Now that's not super important. You'll see the pattern in a second because you're going to also do diagonals beginning with the other side too. So basically you're going to be connecting these three numbers, and these three numbers. So you have to make sure you're connecting 3. So that's why we don't connect the -3 and the 5 because they also don't continue down diagonally to a third number. So 4, 2, and 9 are going to be our first numbers. And what we're going to do is we're going to multiply them. So when you multiply them, you're going to get 72 here, 192 here, and then 3 times -3 times 5 is -45. All right, so then you're going to multiply the diagonally the other way. So -4, 2, 3. Multiplying those, you get -24. Then 5 times 6 times 4 gets us 120. And then 9 times -3 times -8, that's going to get you 216. All right, so then the next step in step 3 is to find the sum of those products. So you're going to add these together and add these together. Pay close attention to your negatives on your numbers. So this one's going to get me 312, and then the bottom one's going to get me 219. And then your last step then is to subtract 219 minus 312. So it's always going to be bottom minus the top. I think this word from actually kind of contradicts what we're supposed to do. So for step 4, I would actually write bottom number minus top number, just so that way we're clear on which order we need to subtract in since the order matters. And then that is going to get us -93, and that is the value of your determinant. So now if you want to do the guided practices with me, you can continue to watch, or if you want to pause it and then check, just go ahead and pause right now. All right, so for the first step, I'm just going to rewrite my first two columns. So -5, -2, -4, 9, -1, 6. Then I'm going to multiply diagonally, starting with the top left corner, working my way down, making sure I'm connecting 3 numbers each time. So multiplying those, so -5 times -1 times 2 is 10. 9 times 5 times -4 is -180. And then 4 times -2 times 6 is -48. Okay? And then for the next one, we're going to start with the bottom left corner and work our way up. Okay? So -4 times -1 times 4 gets us +16. 6 times 5 times -5 is -150. And then 2 times -2 times 9 is going to get us -36. So now we just add them. And you are going to get negative 170 here and negative 218 here. And then for your last step, bottom minus top, negative 218 minus negative 170. That's super important that you remember subtraction is just part of like our formula and that number was already negative. So this actually turns into a plus sign. Okay, or you could also look at it as 170 minus 218. Either way, or use a calculator. Doesn't matter. Calculators are all right now just because there's a lot of math going on here and I'm really teaching you the steps. So it's awesome if you're using a calculator because that means you're going to be definitely getting the correct number every single time. It's just also important to kind of use your brain to make sure those numbers make sense in case you type something wrong. But that's your value right there, negative 48. All right, so for this next one, starting again with repeating the numbers in the first two columns, negative 8, 0, 3, negative 4, negative 5, 4. Multiplying diagonally. All right, so this one is going to get me a positive 40. And then 4 times 8 is 32. 32 times 3, 96. I'm going to double check that on a calculator in a second. But the last one I know is nice and easy because whenever there's a 0 involved, it makes it super nice. All right, I checked the 96. That's good. That's good for the 8 times 5 times 1. All right, so then for the next one, we're going to multiply up 3 times negative 5 times 4. So that is 60. The next diagonal, and you can multiply in any order. When I see these patterns of 8s and 8s, I kind of want to multiply those first and then multiply it with the 4. So that's 256. And then this one's nice and easy because it's a 0, so 0 at the end. And now we're going to add them together to wrap up this process. So here we're going to get 256 plus, oh, this is actually a negative 60 because this was the negative times positive to get negative times another positive to get a negative again. Okay, so 256 and negative 60 make 196. And on the bottom, 96 plus 40 is going to get us 136. So then from here, we're going to subtract in the order from the bottom to the top. So 136 minus 196 is going to get us negative 60. And then example 4 was what we covered in the last video for this same lesson because this is a 2 by 2 matrix that you would use. And then here's where we would actually use the 3 by 3 matrix that we were just learning about. And the part that we just learned is the bottom portion for these. So you would want to find that out first because you're going to use that same number on the bottom denominator of the fraction. So it's really important that you get that number right because if you don't, you're using it in 3 different places. So be super careful during that first step. So let's take a look at how we actually set up the next parts to this. It's basically like a formula that you're going to plug in the numbers where they need to go. So if you look at it when we are trying to find what the x equals, m, n, and p are what they give us. So m, n, and p are what the numbers are set equal to. So this is like our m, our n, and our p. And then if we look at this part here, our b, g, and k are the numbers that are with the y's. And then the c, h, and l are going to be the numbers that are in front of the z's. So basically what you can kind of look at here is when you're solving for the x variable, we don't use the x coefficients, we use this in the spot instead. And then the same thing happens for the y. these are used in the y spot instead of the y coefficients. And then these are used again in the z spots when we're finding the z instead of using the z coefficients. Okay, so we're going to need a lot more space than probably what I have here to solve these because it's a process. All right, let's first determine the determinant. So that's the part that we were doing before. So what they kind of showed us here is that you would find the determinant just by pulling the coefficients of each variable, like so all the numbers in front of the x's, all the numbers in front of the y's, all the numbers in front of the z's make up your 3 by 3 matrix that we are doing in example 2. So let's first make that. All right, so I have these on a separate screen where I can see the equations, but basically this is 4, 5, -6, 3, -2, 7, and 7, -6, -8. Okay, so I got all those from just looking at these right here. Okay, so let's zoom in, get back to this one and solve it. So just like we did before, take the first 2 columns and rewrite it. And then multiply your diagonals. So this is going to get me 64, 245, and 108. And let me just check. This is positive times negative. Get negative, negative, negative. Oops, negative is positive. I think all my signs are right. Okay. And how about I add those up on here? So 108 plus 245 plus 64 is 417. All right, and then the diagonals for the top. So that's 84, negative 168, and that should be negative 120. Okay, and then I'm going to add them together. And get negative 204, and then subtract 417 minus negative 204. And you're going to get 621. So now from here, we have to use this as the number that we are dividing by on every single one of, let me highlight it, these pieces right here. Okay. So actually that means we have 3 more of these to solve. So what we're actually going to do now is solve the x one. So let me zoom in. And again, I have another screen up here so that way I can see the numbers that I need to plug in. So I would recommend that for you too, that you're also looking at the original on a separate screen. So for the x determinant, or I shouldn't say determinant, the matrix, we are going to do negative 14, 47, and 15. And keep in mind, this is like the x spot, like the first numbers, and those are always going to be the answers, like what it equals in those spots. And then the coefficient for 5 and negative 6 are going to go here, negative 2 and 7 are going here, and negative 6 and negative 8 go here. All right, so then after that, remember that you copy down the first two columns. And you solve them by multiplying diagonally. So here I'm going to get negative 224, 525, and then 1,692. And then for the other way to diagonally multiply, I'm going to get 180. I did do a good job making everything the same size, so it's hard to line them up. So then 588 when I multiply those numbers. And then this last one is negative 1,880. So then from here, remember that you add them up. So that's going to give me negative 1,112. And adding these is going to give me 1,993. And then you subtract in this order. And that's going to give me 3,105. And we divide that by the determinant number that we solved in our last one to give us 5. Okay, so that is going to be the x value. Now we're going to move on to the y value. Okay, so when you're doing these determinants, when you're setting up the matrix, you are going to have the numbers that are the answers in the y spots. And then you're going to have the coefficients for the z's in the z spot, which is the same as the one above. But I need to look at which were the x's since we didn't use them in the matrix above, and that is 4, 3, and 7. So those are the x coefficients. Okay, again, I'm going to solve my matrix by copying the first two columns. And then multiplying my diagonals. So when I multiply here, I get negative 1,504. Multiplying here, I get negative 686. And multiplying here, I get negative 270. Now multiply the other diagonals to get negative 1,974. Multiply to get 420. And multiply to get 336. Then add, and that's going to give me negative 1,218. Add, and that's going to give me negative 2,460. Subtract in this order, which actually changes this to plus basically, because you're subtracting a negative. And that's going to give me negative 1,242. Divide again by the same determinant that we found as our first one. And that's going to give me negative 2 as my y value. And then for the last determinant, I keep saying that, the last matrix. Okay, so it's finding the z values. So the answer numbers of negative 14, 47, and 15 go in that spot. And then the coefficients for the x's of 4, 3, and 7. And the coefficients for the y's are 5, negative 2, negative 6. So solving this matrix, copy down the first two columns again. And now multiply diagonally. So when you multiply here, you get negative 120. Multiplying here, you get 1,645. And multiplying here, you get 252. Multiply upward, and you get 196, 1,128, and that's negative. And then the last multiplication is going to be 225. All right, so now we add these numbers, and that gives us negative 707. Add these numbers, and that gives us 1,777. Subtract in this order, which turns that subtraction into addition because you're subtracting a negative. So you should expect to get a bigger number, and that is 2,484. Again, divide by the determinant, which gives us 4. So your final answer are these 3 numbers here, the 5, the negative 2, and the 4. And we write them as an ordered triple of 5, negative 2, 4. So it should be in the order of X, Y, and then Z. All right, so if you are watching this and you're like, wow, that was a lot of work, it really kind of can go fast. But I made a spreadsheet that we're going to reference in class to kind of help us organize this information too. Because really these kind of look like cells of numbers like a spreadsheet would be. So it's kind of easy to organize your numbers on graph paper or digitally on like Google Sheets. So right now, these examples, we are going to do the guided practices on a Google Sheet. So reference that document to finish out the rest of those.